Now we're going to take a look at what's called a polar equation. You can tell it's an equation because it has a what? Equal sign, and in this case it has both r and theta in it. We did a few equations for 9-1, but that was just r equals, say, 2, or theta equals 45 degrees. Here, r and theta are both in there, so what we're going to do is we're going to get a bunch of ordered pairs that are actually part of this graph, and then we will find out what actually happens. So the easiest thing to do is just decide a spot to start and go from there. The statement was, why are sine and cosine in here? And in fact, sine and cosine in here is much better than having, say, tangent or secant or some of the other ones. And really what sine and cosine do is they constrain the graph, because sine and cosine can only get so big. They can only get to 1, and they can only go as low as -1. And so they really do constrain the graph for you a little bit, which is kind of nice. Tangent is pretty much all over the place if you try and graph one with that. And I'll never ask you to do one of those by hand in polar. So let's just start with theta. Theta is, again, the what? The angle. What's probably the most logical place to start? 0. And all we're doing basically is an XY table here, except it's a theta and r. Because really, do you agree this is where r is right there? Is that column? Because that's what r is supposed to equal, is 5 sine of theta, right? So what you need to do now is basically put 0 right there. And what is sine at 0? 0. So in other words, sine at 0 is 0. You take that times 5, and you still have
0.
So your ordered pair, so here's theta, here's r. Everybody see that? So r is this 0 right here, and 0. Is that a point that we can graph? Yeah, all right. Right there. 0 degrees and 0 radius. It's the center. What's probably a logical place to go next? You don't want to jump too far. I'd say, why don't we go to 30 degrees? So now what does that mean? You're putting 30 degrees in for theta. So you find sine there. So it's square root of 3 over 2 comma 1/2. And so what is sine there? 1/2, but I have to still, so this much of it's 1/2. I still have to take it times 5. So what is 1/2 times 2.5? Very good. Now, here's where some people struggle. What is the ordered pair? 2.5 comma 30 degrees. Very good. Because this first one, did it really matter on this first one which 0 you put first? You're still going to be right. So this one here, you go 2.5 comma 30. So here's 30 degrees, right? Right out there. And we're supposed to go 2.5. Well, here's 1, 2.5. Get as close as you can. Do not connect them yet. Well, we could go to 45 if you wanted to. I'd say let's just keep going up by the same increment. We went up by 30, so let's go up by 30 again. So 60. Yeah, and how about up there at 60, what is the sine value? Square root of 3 over 2, which I then have to take times. So would you please figure that out in decimal form for me? Take the square root of 3 over 2 and take it times 5. .3, approximately 4.3. Again, make sure you write the ordered pair right. We're so used to having x first and then getting y. So how do you write it? It's 4.3 comma 60 degrees. So you go to 60 degrees, which is this one here, and you go 4.3. So 1, 2, 3, 4.3. I would say keep going up by the same increment. So you put 90 degrees in there. So we're way up on top now. Sine is 1, which you have to take times. So you get 5. Any questions where these numbers are coming from? Again, imagine trying to do this without knowing the unit circle. So here's 90. You go out 1, 2, 3, 4, 5. So far, do you agree that's pretty much what we got?
I agree.
All right. And what's going to happen with polar coordinates is there'll become a point that you know what's happening. On this one, we don't quite know yet, so let's keep going. 120, which is right over there. And what is sine there? Well, once we do everything, isn't it going to be 4.3 again? Because isn't sine square root of 3 over 2? Then we're going to take it times 5. Didn't we already get that number? You see what I mean by going up by the same increment so you can save yourself some time? Instead of jumping all over the place, you're not going to get a pattern. Why is there a pattern? Because it's based off of a circle. So do you agree this is it a positive 4.3 though is the question. Is it possible to get negatives though in these? Yeah, it is. But that one, why is it positive? Because sine is positive in the second quadrant, correct? So it is 4.3. So it's 4.3 comma 120 degrees. So you go to 120 and you go 1, 2, 3, whoops, 1, 2, 3, 4.3, right about there. What would be our next theta value then? 150, okay. And 150 kind of pairs up with which one then? Yeah, it's going to be 2.5, and it pairs up with 30 because it would be a half again, right? And then times 5, so it's 2.5. So 2.5 comma 150. So we're doing good. 150, 1, 2.5. All right. Well, what comes next? 180? 180. Focus. Are you sure? So you go to 180 degrees and you go out 0, so we're right back to where we started. Agreed. Now, it would be nice to know that we were done, but we don't. There are a lot of options from here. What can happen is it can just trace itself again. It could do that. It could actually sit here and form a figure 8, and then it could shoot out that way, and then it could shoot out this way. That's where the flowers come, okay? Right, but sine is going to start becoming negative here pretty quick. And so you got to watch out. Or what it can actually happen is it can go like this and then kind of trace in on itself. Okay, so once you know exactly which of those options is happening, that's when you can stop. Okay, now it could be this figure 8, it could be the flower, it could just trace itself again. So what we need to do is let's just do one more point, kind of figure out what's going on, and the next point would be
210.
210, okay, which is this one here. And sine's the y value, agreed?
Yep.
But sine is all of a sudden negative because we're in the third quadrant. And so it's negative 1/2, agreed? But I still have to take that negative 1/2 times 5, so we're at negative 2.5, so we got negative 2.5 comma 210. Now 210's right here, agreed? So the positive would actually be coming out here towards the third quadrant, so the negative actually shoots into the first quadrant, so isn't it the same point we already had? Doesn't it basically graph that point again? Because if this is 210 shooting out this way, that's the positive direction. The negative direction would be completely out the other way, which really means 30. That's what the negative means. So do we know what happened? Yes, we do. Do not connect it with straight lines because this is based off of trig, so it has to be it should not be a circle. It should kind of almost look like a balloon, really. Yes. Okay, thank you.
For me, it looks like an alien we have.
So any questions on that one? The beautiful part is if you can stay with a consistent system, you should see some numbers. Again, if I jumped all over the place, we wouldn't know what was going on. And I will eventually show you how to graph these on the TI-83 if you can show me you can do it by hand. That'll save you lots of time. So let's try another one. What's different about this one? Well, for one, it's cosine, most definitely a big difference. Yeah, it's kind of a two-step deal. That's what we're saying here. I think the 2 is kind of messing things up here a little bit, right? Because it's 2 plus something, so that's a little different. I think you can handle it. But I think we can agree basically this column is R. And is there at least some sine or cosine that's constraining this graph? Yeah, it's keeping it under control. Okay, just like in the last one, sine kind of kept it under control. If there was no sine there, it would have gone out of control. Okay. So here we go. Probably start at a logical place of 0 degrees, of course. And so let's maybe get a unit circle over here this time. So what is cosine at 0 degrees? 1, and then you have to take that times, which is and then you have to add. So it's, do you see how that pattern that I told you about in last chapter, that you kind of go right to left a lot of times with the trig? And so what is the ordered pair? Very good. 5 counts 0 degrees. So 0 degrees is, you know, your x-axis, your positive x-axis, and you go out 1, 2, 3, 4, 5. Okay. What I would like you to do right now is get a few more of these points on your own. I will come around and see how you're doing. All right, let's bring this back together to make sure we have plenty of time for the last one. It's not that it's any harder, I just have to say some stuff about it. So did you go to 30 then? Is that where most of you went for your second one? That's probably the best place to go. And again, probably keep going up by that increment. So cosine at 30 is? Square root of 3 over 2, you take that times 3, you add 2. I on mine got 4.6 when I did it. And so it's 4.6 comma 30 degrees. And so you go ahead and you go to 30 degrees, you go 1, 2, 3, 4.6. So not quite out as far as the other one was. And then you go to 60 degrees. 60 degrees is the 1/2. That's kind of the nice easy one. But 1/2 times 3 is 3/2 or 1.5. And then you add 2, so you're at 3.5. So 3.5 comma 60 degrees. And so you go to 60 degrees, 1, 2, 3.5. So the last one kind of went out as we started. This one's starting out and kind of working its way in. That's because of the difference in the trig. This one's cosine, the other one's sine. So 90 degrees we're looking at up here. And cosine is? Zero. Now a lot of people write 0 down in this column then. Is 0 what you should be writing in this column? No, because you got to take 0 times 3, which is still 0, but then you have to add 2, so really it's 2. So you can see that if you did that one wrong, then your graph is going to start looking a little bit weird. So that goes there, and now I'll help you out and fill these in, because I know that you could all manage doing this. So we go to 120, and I got 0.5. So it is 0.5 comma 120 degrees. So 120 is at 0.5, so really way far in there. So do we know what's happening yet with this graph? Do we know 100% what it's doing? Unfortunately, not yet. So then you go to 150. I got negative 0.6. Here we go. Here's 150, agreed, out here. Negative 0.6 has to shoot out the other way. So negative 0.6 is actually over there. So do we know what's happening now? Not really. So let's go to 180 degrees. 180 degrees, well, we're looking at over here, cosine being negative 1, which you take times 3 is negative 3 plus 2 is negative 1. Oop, I forgot to write this one. So 180 degrees is actually over here, so negative 1 is actually that side. So of the options that I told you could happen, which one do you believe this one to be? There are going to be spirals, but it's not going to be this one. Okay, remember I told you it can kind of do the figure 8. It can trace itself. And what was the third option? It have a smaller version of itself on the inside, and that's exactly what's going to happen here. A little, I guess you'd call it loop-de-loo in the middle there. Because once you go to 210 is actually when the pattern starts to repeat itself. You get negative 0.6. You see, basically it's going to work its way right back up this thing is what's going to happen. So we got negative 0.6 comma 210. You just had to wait a little bit longer for the pattern this time. So we're at 210, we go out negative 0.6, so it's out the other way. And then I got to get this out of the way. And so if you see that, what can we anticipate for 240? Yeah, 0.5. You do the math, you find out it is 0.5. It's just working its way right back up. 0.5 comma 240. So 240 is back out on this side. So far it's come around this way and done a little loop-de-loo. Now it's going to shoot back around and connect itself. Loop-de-loo is definitely not the technical term, but I think you should be used to that by now with me. 270, yeah, it's the 2. And then 300, I'm going to run out of room. 300 brings it right back to the 3.5. So 3.5 comma 300. And then 330 is back to, I'll try and squeak it in there. 330 is back to 4.6. So 4.6 comma 330. And how about 360? We'll be right back to 5. Okay. So where's 240 here? Did I do that one already? Yep. And then we go 270 is back out to 2. 300 is out at 1, 2, 3.5. Again, are these the only points on there? No, there's a ton of points on there. So basically, if you saw it graphed, it would go in like this, loop around, and shoot right back out the other way. It should be symmetric. Mine's a little off. But you get the idea. If we did the next point, where do you suppose it would go? For example, if we did, what, 390? Yeah, it would be just the same exact thing as 30, and so it would just trace itself again. Okay. Any questions on that? What do you notice about this one? No sine and no cosine. And what did I tell you earlier that sine and cosine actually do? They kind of contain the graph. Is there anything to slow this down? So the bigger this angle gets, the bigger the radius is going to get. Now, here's your two choices. You can still do degrees here, but realize when you get to 30 degrees, you take 30 times 2, your radius is 60. So either you make each one of these circles, say, 60 for a radius, or use your other option, which is not degrees, but radians. And really, do I need to know, like, sine at any of these radians? Or cosine? No. Do you have to go find the decimal? Yes. And that's a lot of times what I would do if I was doing this particular table. Or go ahead and, like I said, make each circle 60 for your radius. It'll work the same. So here we'll put theta. Here we'll put 2 theta, which is otherwise known as r. And here again we'll put... I know that we never used to make a column for the x, the ordered pair, but I think it's important for these because people get them flip-flop too much. So let's just go ahead and start with 0. So you take 2 times 0 and you get 0. So 0, 0 is where we start. And might as well just go to pi over 6. And all you have to do then is take pi over 6 times 2, which is pi over 3, and find out what that is on your calculator. You're not taking sine of that, you're not taking cosine of that. Just take pi over 3 on your calculator. It should be right around 1 somewhere. So 1.04. Now how are you going to write this though? This is the one I'm most concerned about. How are you going to write the ordered pair? 1.04 comma. Yeah, that's the thing. It's pi over 6 is what I put in. Okay, so you can say 30 degrees or just say pi over 6. You should know by now that that's 30 degrees. So for there, you just go out a little past 1. Now, what is the next radian then? If we're going to follow the pattern we did before, same increments. You could do pi over 4 if you wanted to, but if we do same increments, it'd be pi over 3. Take that times 2 and you get 2 pi over 3. And that's something you have to figure out on your calculator. And you're expecting it to be bigger or smaller? We just took 2 times pi over 3. 2 point. So 2.1, is that right? So pi over 3, 2.1, so 1, 2.1. And where are we going to go next if we keep the same increment? 90, which is pi over 2. Again, you notice this is me really checking how much you remember the radians. Pi over 2 times 2, which is, I hope you know that one, 3.14 as a decimal, of course. Pi over 2, and then 1, 2, 3, 1, 4. As you can see, this is starting to move rather quickly. What's next? 2, what is it? Yep, 2 pi over 3, which when I double is 4 pi over 3, and your decimal is 2, okay? 4.2 comma 2 pi over 3. 1, 2, 3, 4.2. And whenever you have one like this, again, it's going to keep going on without bounds, so it is truly a spiral. And once you get off your graph, then stop. You don't have to sit there and keep going. What's after 2 pi over 3? 3 pi over... Nope, not 3 pi over 4. Yep, 5 pi over 6, if we follow the increments. Yep. Is 10 pi over 6. When you double it, 5.2 is correct. 5.2 comma 5 pi over 6. 5.2. All right, 1, 2, 3, 4, 5.2. And I'm guessing the next one's probably going to be off the graph. Next one is pi. 2 pi, I'm guessing, is about 6.28. That'd be my guess. Or 6.3. So about there, and we're done. Except one little thing. Yeah, that thing is never, ever going to stop. And it's never going to come back to 0. Because there's no sine or cosine to make it come back to 0. Or tangent, for that matter. So whenever you see one without sine, cosine, or tangent, you should know right away it's going to be a spiral. You might want to go to radians, do it that way. Questions? Again, prove you can do it by hand. Then we'll have some fun with the calculators.